Okay, I'm on page 6 of your 3B class packet. And a few days ago, you should have watched the video where we reviewed how to graph a system of linear inequalities. I'm going to review one of those problems right now, just for those who are still confused, and then we'll go on to new material. So again, a system means you have two equations, and we're going to graph both of these equations, but the answer is not going to be where they cross. Instead, the answer is going to be where the shading overlaps, because if you have inequalities involved, you have to shade to identify where all the solutions are. So if I start with my top equation, first of all, neither of these are in slope-intercept form. So I'm going to have to start by converting these. So I'm going to add 2x on both sides, and I'm left with y is greater than 2x minus 3. Again, your goal when converting these is you want the x to go on the right-hand side, or anything on the same side as the y to get moved. And then if there's a number in front of the y, you would then divide. But in this case, y is by itself. So that's my top equation. So if I graph that, -3 is my starting point on the y-axis, and my slope is 2 over 1. Positive 2 over 1 means I'm going to go up 2 to the right 1. It does not have an equal to underneath it, so that means it's going to be a dashed line. And then to figure out which side of my line I'm going to shade, I'm going to use the test point 0, 0. So that means for both y and x, I'm going to plug in a 0 and see what it simplifies down to. You can always use the test point 0, 0 unless your line actually goes through that point. Then you would have to pick a different point on your graph to test. But if you can use 0, 0, I would, just because that's the easiest to plug in. So this will give you 0 is greater than -3. That is true. 0 is bigger than all negative numbers. So since it's true, that means I'm going to put my pencil at 0, and I'm going to stay on that side of the line, because if 0 is true, that means everything on this side of my line is a solution. Now I'm going to do the second equation. So I'm going to start by minusing 2x on both sides. So negative y is greater than or equal to negative 2x minus 2. Now, there is a number left in front of the y. That's technically a -1. So I still have to divide everything by a -1. And whenever you divide by a negative number, we know the rule is we have to flip the sign. And then negative 2x divided by -1 is positive 2x. And negative 2 divided by -1 is positive 2. So now, to graph this one, my starting point's at 2. And again, my slope is 2 over 1, so up 2 to the right 1. So because these two lines have the same slope, but different y-intercepts, they are actually parallel. This one's going to be a solid line because it does have an equal to under the inequality. Now, when these were equal signs, parallel lines would be no solution because they would never intersect. But that's not necessarily the case with inequalities, because we are checking to see if the shading overlaps. So if the shading overlaps, then there's still a solution. So we still have to figure out for my solid line, which side of the line I'm going to shade, everything to the right or everything to the left. So I can still use 0, 0. And that gives me 0 is smaller than or equal to 2, which is true. 0 is smaller than 2. So if I'm looking at my solid line now, if I put my pencil at 0, which is on the right-hand side of the solid line, that means everything to the right of that line will get shaded in. Because if 0, 0 is a solution, everything on that side is a solution. So the shading where it overlaps is actually between your two lines, and that's where I'm going to color in dark to indicate that's where the solutions are. So the solutions only lie in between the two lines in this case, because that's where the shading overlapped. So that's what you've hopefully been practicing in your notes and watching these videos. Now I'm going to move on to this next section. So I'm going to go to page 8. So page 8 says Minimize the cost, c equals 2x plus y, with the given constraints. So what we're going to do I'm not going to worry about this equation right now. First, I'm going to graph all these lines onto my coordinate plane. So the first one, x is greater than or equal to 2. This is the one exception where it's a vertical line, the slope is undefined, it is not in the form y equals mx plus b. So at 2, and it's going to be a solid line, I'm going to draw a solid vertical line. And there's my first one, graph. My second equation, now this is actually two horizontal lines because you can break this inequality up into two different equations because we have two inequality signs. So if you read this, my first one says y is greater than 3, so y is greater than or equal to 3 technically. And then my second equation, if I go the other direction, is y is less than or equal to 6. So if I write it out like that, I can see that I have two different horizontal lines because if it's in the form y equals a number with no x, there is no slope, slope is 0, it's a horizontal line. So at y equals 3, I'm going to put a solid horizontal line. And at y equals 6, I'm going to do a solid horizontal line. And then my last one. This one I have to actually convert to y equals mx plus b. So I have to start by subtracting x on both sides, and I get y is less than or equal to negative x plus 10. It is now in the form y equals mx plus b, so I can go ahead and graph this one. Now my starting point is 10, which it only goes up to 8. So I'm going to just extend my graph here a little bit, just so I can graph the number 10. Okay, so this one, my starting point's at positive 10, so 6, 7, 8, 9, 10 right here. And then my slope is negative 1 over 1. So it's negative, so I'm going to go down 1 and then to the right 1 because over a positive 1. So down 1 to the right 1. And then that's also a solid line. Okay, so I'm just going to darken in my lines here. So I have this one I just graphed. I have this vertical line, that was my first one. And then I have my two horizontal lines. So what you're trying to find is the region contained between all four of these lines, which would be right in here. This area right in here is the region that is contained between all those lines that I graphed. I wouldn't want to color up here because that goes above this horizontal line. I want to include the two horizontal lines, the vertical line, and then my line that had a negative 1x slope. Everything in this section here is contained between all those four lines. So with that, I have 4 points. 1, 2, 3, 4. 4 points that connect that region that I'm going to write down. So this point's at the point over 2 up 3. This point is over 2 up 6. This point is over 7 up 3. And lastly, this point is over 4 up 6. Those are the 4 points that create that region between those four lines. So what I'm going to do to answer the question, I'm trying to figure out which one gives me the smallest number, because it says minimize, given this cost. So I'm going to go here. Every point has an x and a y. And I'm going to plug in all those numbers for x and y and see what I get. So if I start with the first one, it would be 2 times 2, because x is 2, plus 3, because y is 3. 2 times 2 is 4. 4 plus 3, that gives me a 7. Now I'm going to do it the next one. So plugging in a 2 for x, 2 times 2 is 4, plus 6, because y is 6, that gives me 10. Now for my next one, plugging in a 7 for x and a 3 for y. 2 times 7 is 14. 14 plus 3 gives me 17. And my last one, plugging in a 4 for x and a 6 for y. 2 times 4 is 8. 8 plus 6, 14. Okay, so which one of these gave me, because I'm looking for the minimum, which one gave me the smallest number? That'd be 2 and 3. So there is my answer for this one. So yes, a lot of steps involved. So let's go ahead and practice the next one on page 9. So first, I'm going to graph all these lines that are given to me. So this one is a vertical line at 0. Okay, straight up and down. When it's an x equals, it's always straight up and down, vertical line. Y equals is a horizontal line because there is no x. So a horizontal line at 0 is my second equation. And these last two, I'm gonna have to convert into slope-intercept form before I can go ahead and graph it. So this first one, I'm gonna have the minus x on both sides. 2y is less than or equal to negative x plus 8. Divide everything by 2. And I'm left with y is less than or equal to, this would be negative 1/2 x. And 8 divided by 2 is 4. So now if I go ahead and graph this one, this starts at positive 4, and then it'd be down 1 to the right 2, because my top number is negative, my bottom number is positive, so down 1 to the right 2. And I'm going to plot as many points as I can, because I'm trying to figure out where that contained region is going to be. So there's my third line. And then my last one, converting this, subtract x on both sides. That gives me negative y is less than or equal to negative x plus 2. I still have a negative 1 out in front of my y, so I now need to divide everything by negative 1. I divided by a negative, so I'm going to flip the sign. Negative x over negative 1 is positive 1x, and 2 divided by negative 1 is negative 2. So now to graph this one, my starting point is at negative 2. My slope is positive 1 over 1, so up 1 to the right 1. And these are all solid lines. So this time I have 1, 2, 3, 4. Okay, so I got 4 lines. I'm gonna just darken them in here. I got my vertical line at 0. I got my horizontal line at 0. And then I have my 2 lines that I had to convert to slope-intercept form. So again, I'm trying to find the region that contains all 4 lines. This area right here contains all 4 lines. Like I wouldn't want to color down here because that goes below my horizontal line and it wouldn't be included. So with that, I have 1, 2, 3, 4 points again that create that region. My first one, 0, 0. Next one would be 0 up 4. Next one would be 2, 0. And then over 4 up 2. Once you've written down the points that contain or create that region, I'm now going to plug all those numbers in to x and y into that equation here at the top, and this time I'm finding the max. So if I plug in 0 for x and 0 for y, 2 times 0 is 0, 0 plus 0 is still 0. Now if I do this one, 2 times 0 is 0, plus 4 is 4. Now I'm plugging these numbers in for x and y. 2 times 2 is 4, 4 plus 0 is 4 again. And then my last one's for x and y. 2 times 4 is 8, plus 2 is 10. So I'm looking for the max. The max number here is 10 at the point 4, comma 2. So that would be my answer for this one. Make sure you work on your homework packet and rewatch these videos if you need help or clarification.